Hello everyone and welcome back to Just Finish Coding. I'm Sriram and this video is part 9 of our Geometry Dash game on Scratch 3. Now in case you've not watched parts 1 to 8, I will leave a card for you right here. So in parts 1 to 8 we did quite a lot of code, and in this video we'll be completing the flying animation with the flying particles. Now I brought this up in the last video when I did the player particles, and this will basically be the player particles but for the air instead of the ground. So before we begin, I'm going to correct one error which I made, I believe in part 6 or something, and that is within the flying changes. So you can zoom into your tick when I receive tick message, and you can change it from mode, if mode is ground, set mode to air, to set mode to flying. Now I made this video, I recorded this video the last time and I couldn't find this bug and I ended up cancelling the whole thing, and this was the reason for it. So make sure you correct this before you do anything else, because this is going to be pretty crucial. Alright, so now you can head over to your stage sprite, and within variables you can create 3 different lists. Okay, not variables but lists. So the first list is going to be called flying x positions. All of these are going to be by default set for all sprites, so you don't have to worry about that. You can actually copy this entire name because the others are going to have pretty similar names as well. So that's flying x positions. The second one is flying y positions, and the third one is going to be called flying directions. Okay, so they're all they have fairly similar names. I'll explain what each of these are going to do, but just follow me along for now. So I'll be clearing all of these lists at the beginning, and to do that we just need to make sure we delete all of those items. So see, delete all of flying x positions, duplicate that block for the y positions, and also duplicate that block for the directions, because we need to delete all this stuff. Alright, so once we're done with all of this, we can set them up to their initial values. Now at the start, all of these lists are going to have 10 elements each, and they are all going to be empty. So to do that, you can grab a repeat 10 from the control section, head again to the variables category, and you can say add thing to flying directions. Now you can change that thing to a space, and you can just say flying x positions first, and duplicate this once again the way we did the last time. So add it to flying y positions and add it to flying directions as well. So at the start of the game, we'll be having these blank lists, and then we're going to add 10 items to them, which are all empty. So I'll explain what this does now. We can actually go up to the player, and we can go up to our earlier x position. Since we are experimenting with this, you can see go to I think the coordinate was 2300. So go there, and I'm going to click OK. So yeah, there we're very close to the flying engine. And now you can see that when we are flying, we'd want a trail of smoke to go behind us. We'd also want that smoke to go to this particular position, and remember it's constantly going to be moving to the left as well. So we'd want to calculate a particular position for each smoke wisp to go to. Now to go in a pretty neat path, we need to know the direction of this player, we need to know where his previous x position was, and we need to know where his previous y position was. And we'll be calculating all of that within our player, and we'll be feeding it into these different lists, and using those values from the list, we'll be sending our various flying particles clones right there. Now this might have seemed like a big oversimplification, and it looks like it may be very complicated, but trust me, it's not. It's actually simpler than it looks. Basically, since we have 10 blank elements within each of these lists, we're going to have 10 different clones. Now you could play around with that, maybe change it to 11 or 12, but 10 works best, and I tried the same thing with another bunch of numbers, but 10 worked the best. Okay, so I'm going to continue now. So let's head over to the player actually, because I'm done with the stage. So within the player, things are fairly straightforward, right? We can just have a single list to make sure, not a single list, but a single block to make sure we do everything in one place. And before I make the block, I want to make sure I go to some empty room, because I don't want to have to overwrite and move stuff again. So let me go to this bottom corner here. Let's say make a new block, and I will call this edit flying lists. Maybe I'll do everything in lowercase. So edit flying lists. And you can click run without screen refresh because we basically aren't going to be moving the sprite or anything like that. So within edit flying lists, first of all, let me create a counter because this is useful within loops. So set for the sprite only, I'll call this counter C, and you can hide that sprite. So initially we will set C to be 1. Okay, actually not 1, we'll be going backwards because we'd want the first clone to be the wisp that is nearest to the sprite. So the first one is going to be right here, the second one is going to be behind, the third one is going to be even more behind, and so on until we get to the 10th. Obviously, you know, the sketchy diagrams I made on the screen were too big, and the real clone is going to be much smaller. So set C not to 1, but we can set it to whatever the length of any of these lists are. In this case, we know it's 10, so we can just say set C to 10, and we don't really have to bother because the length is always going to be 10. And we can repeat 9 different times. So remember, we're going backwards each time, so we're changing C by -1 here. So for C to go from -10 to 1, it's going to be 9 different -1s, right? So that's what we're doing here. So we repeat 9 times, and each time we change C by -1. That's what I said, right? So change C by not 1, be careful here, but -1. Now we haven't really replaced any of the items yet because that's the whole point of this function, right? We want to get those values. So to enter in those values, you can use the replace block. So you can say replace item, first of all, replace item 1 or first let's say flying X positions, and we'll be replacing it with not some, you know, value which we have, but we'll simply be replacing it with the previous one. So we're basically going to make sure we eliminate the 10th item of this list, and we'll add in the first item of this list, and we'll make the rest of the list go down by 1. So the first element which was there is going to become the second element, the second is going to become the third, and so on till the 9th element becomes the 10th element. Now this is obviously going to be in reverse, but I'm pretty sure you get the idea. So we'll be starting from 9 to 10, and the exact opposite. We're changing C by -1 instead of +1, but it's the exact same thing happening. So let's say replace item C of flying positions with, and again you can head over to variables and grab item whatever of flying directions, change that to flying X positions, and you can see item C -1 of flying X positions. This is what I mentioned. For example, if C in this case is 2, then the second element is going to be replaced with the first element, replaced by the first element on element number 2. So this is what's going to happen, right? And now we can duplicate this whole thing and duplicate this once more, and all of these are going to be for flying Y positions and also for the flying directions. Now you obviously have to change those list names here as well. So let me change this to flying Y positions, and let me change this to flying directions. So that's going to be all the, list moving that we're going to do if you want to think about it that way. And now we need to make sure that we actually change the latest item. In this case, it's going to be item 1 because item 10 is going to be the oldest element, and it's going to be removed. So let's replace item 1. Head over to variables and say replace item once again. Or you can change this from flying directions to X positions first, and you can simply say replace it with X. That's it. We don't really have to make any change at all. Next we can say replace item 1 of flying Y positions. So flying Y positions, and here you can use this minus block once again. So let me duplicate this, put this right here, change this to Y, but instead of just saying change it with Y, I'll be saying change it by Y -8. And the reason I'm doing this is because if you look at the costume of the flying player, you can see that the center of this costume isn't really where we'd want the wisp. We'd want that to be slightly lower, and this thing is pretty huge, right? So if we just leave it to Y, then the position that we're going to go to is right here. So our flying wisp is going to start here instead of starting below here and going out. So that's the general idea. I hope you understood that. Let's head back to our code, and we can change finally the flying directions first element with, and this is where it gets a little bit complicated, but it's fairly straightforward. I mean, if you know it's going to be trigonometry, it's going to be very simple, but just follow me along. First grab a minus, then you can put a 90 first there. Then you can use this round operator, which is in operators as well. And you can see you can grab this abs off, change that to be a tan off. This one, not tan, a tan off, which is inverse tan off. And now you can grab a divided by, and you can say y velocity divided by 8. Now this may have seemed pretty strange, but the logic is very, very simple. So I'm basically having a right angle triangle with 8, which is the x velocity on one side, and y velocity on one side. So I'm just trying to find out whatever angle that is. And the angle in this case is the angle with the y-axis, right? That's the direction, not the angle with the x-axis. So the angle in the y-axis is simply going to be, tan of that angle is going to be x velocity, which is 8 by y velocity. Now when I tried that code, however, I started to get a lot of errors. So instead I replaced it with this, which is pretty much the same code. I'm just doing 90 minus and flipping this. But it did work this time. So I guess it's just an error with Scratch. So just copy me along. And this is going to be it for the player sprite. Now we can head over to the, I think it's called the flying particles, right? Yeah, to the flying particles, and we can start to make our changes here. Actually, never mind. I'm going to head back to the player, and I forgot to do probably the main thing, which is to use that function, because we completed our function and didn't really implement anything. So let me head into the, you can do this in the start game message. So you can go right here, get a little bit of space down because we're going to need some space. So I'm going to drag this down and I'm going to drag this up. So that's going to give us some space there. Okay, let me drag this up now. So what we'll do is we'll be checking if mode is equal to flying right here. So head over to if, grab an if then, say is equal to, and we can say if mode is equal to flying, right? That's the mode which is going to be the case after the ground mode. In case this is true, then we'll simply be implementing this function which we just wrote, or this block which we just wrote. And you can put this right after the player engine. That's going to be it. That's all we need to do in the player. Let's head into the flying engine now. So to start this flying engine off, we can start with a regular init. So head into events, grab when I receive init, and we'll be checking first of all for all the clones. So in case there are any clones, which there won't be at the start, but they will be when we do start the game, we will simply be deleting everything. So grab, okay, not an if then, but a repeat 1. So say repeat 1, delete this clone. So there we go. Next we can set our size to be 100 because I played with the size earlier and it's important we set it right back. So say set size to 100. Then we can hide this particular sprite. Remember, this is not the clone, this is only the sprite. And then what we can do is we can set our ghost effect, which is our transparency, to be 10. That's going to be the start, okay? Next, we can set this clone variable, which I haven't made yet. So I'll be making right now. It's the same variable which I use for the other sprites. So you can set it for the sprite only, click OK. We can set clone here, clone here to be yes. And we will also be creating another another private variable. And this one is called clone number. And this is going to be useful when we're choosing the particular element from that list. So this is going to be, yep, it is a private variable. Let's hide those two. Let me set, let me set clone number to be 1 initially. Now we'll be repeating 10 different times because like I said, we'll have 10 of these clones as is the number of elements on those lists. Repeat 10 times. We will create a clone of ourselves each time. We will also be changing the size so that it gets smaller and smaller each time, right? So we can say set, not actually set size, you can say change size by -3 so that they get slightly smaller. And you can also change ghost effect by 3 so that things get more and more transparent as they progress. So set change ghost effect by 3, and we can also finally change the clone number by 1 because at this point the clone number is going to be the same for every single clone. So say change clone number by 1, and finally once we are done with all of this, we can set that clone variable back to no because that's going to be the, that variable is going to be set now for the sprite and not for any one of those clones. Now, before we proceed, I'm actually going to finish the go to coordinates function, which we pretty much use everywhere. So let's say make a block, say, make the block, say go to coordinates, there we go, I spelled it right. You can run without screen refresh, and within this go to coordinates, you can simply say go to, x is going to be x minus scroll x, and I'm pretty sure I didn't create the x and y. So create for the sprite only x and create for the sprite only y. Okay, those are going to be the two. Let me hide both x and y. No sets here. So let me set x to x minus scroll x, and let me set y to simply be y. And that's going to be it. Okay, that's all we need for the go to coordinates function. And finally the tick function, because this is what is really going to make all the difference and make the flying particles appear. So head over to events, grab a when I receive tick. So when we do receive tick each time, we are first of all going to be checking if the particular clone is actually a clone, because it shouldn't be the sprite. So you can say if the clone variable is set to yes. After this, you can grab an if else, not an if then, but an if else in this case. Now you can check if mode is equal to flying. Now in case mode is equal to flying, then we'll be doing all the fun stuff. But in case it is not equal to flying, then we simply want to hide it, because in this case it would mean that we are in the ground, and when it's the ground we'll be showing the clear particles, right? So head over to flying particles once again. If it's if the mode is ground, which means it's not flying, you just hide it. And in case it is, the mode is flying, then we need to check whether this we need to check whether it's this particular item, right? So you can grab once again an if else. So if else, and this is really only relevant during the beginning, because once we go past the 10 ticks, the list is going to be filled up entirely, and as a result, I mean, we're going to have 10 positions for these clones. But when we do start off, we're going to start with a single wisp. Then in the second tick, it's going to change into 2 wisps, because the second element is going to get filled up as well. Then the third element gets filled up, and finally we go on until all the 10 elements are filled up, in which case in the 11th tick, we'll be deleting the 10th element and we'll be getting a new element, right? So that's the idea. So we can simply check here if grab an equal to, actually you can grab a not, right? So we'll be checking if it's not blank. So within this, you can simply put blank or whatever you happen to put here, right? In my case, it was a space, so I'm doing a space here as well. So there's a space here, so there you can see. So we'll be checking if head over to variables, grab this item, and you can change that to anything. I'll do flying expositions. You can see item clone number of flying expositions is not empty. So in case it's not empty, then it means we can continue our code. But if it is empty, then we'd simply want to hide the clone. Okay, so now let's go ahead and get into what happens if it is not empty. So if it's not empty, then we can set our x and y values accordingly. So set x to whatever that element happened to be. So you can see item clone number of flying expositions. We can set y to be item whatever clone number of flying y positions was. And finally, we can point in direction of whatever the element in direction was. So to do that, you can head over to motion, say point in direction, and you can change, not change, but just duplicate this and say change it to clone number of flying directions. Now we also need to make sure that the sprite goes to the particular location. So to do that, we can simply just put in that function, which we just coded, right? Go to coordinates. And obviously, if this is the case, then we need to show ourselves. By default, it's going to be in hide, and it's important we specify the show. And that's it. That's all we need to do for our flying positions. And I think if you have this much done, it should work for you. So I'm going to hit the green flag and just test this out a little bit. And you can see that although I wasn't very good at manning this, since my computer is basically over lagging, you can see that we do have a little nice wisp. Now it's not perfect and it could sure be made a lot better, but it is a pretty neat, flying particle, and that's it I'll be doing in the flying animation. Now you could make this all come neatly, but when I did do that, the movement of these particles was very abrupt. So this is the best that I could do. In the next video, we'll be making sure that we can touch the coins and we also collide properly. If you've enjoyed this video, please make sure you leave a like, and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching, and I'll see you in the next video.